Visage is a prototype user interface environment designed for people working in information-intensive domains. Typically, these are people who must analyze and explore information from many different sources with many different applications. Even in a simple case, an analyst might work with a database, spreadsheet, graphics program, and geographic information system. Each application may work well for particular analyses or information, but until recently, their interfaces have acted as walls that prevent people from combining information from different displays into a common work area. The recent trend towards document-centered approaches enables one to embed tables, graphs, text, and images from different sources into a single document. Visage goes beyond the document approach by taking an information-centric approach, where all data objects appearing in a display can be manipulated using a common set of operations. So information can be selectively dragged across displays to be integrated in new ways. Visage is a prototype user interface environment for exploring and visualizing information. It combines the web's data navigation interface, developed at Maya Design Group, and the SAGE Intelligent Visualization Project at Carnegie Mellon University. The Visage environment has four main components: a unique drill-down and roll-up data navigation technique, the information-centric drag-and-drop user interface paradigm, intelligent visualization tools that automatically create new graphics, and briefing features for highly interactive presentations. Let's consider an Army analyst who needs to explore the supply needs of a particular group in an Army organization and uses an outliner table that shows information hierarchically. The goal is to learn which units need the most supplies and how to deliver them. We start from a single point in a data network, in this case, an object pointing to an entire database of Army supply requirements. A menu is displayed of alternative dimensions or relations along which an analyst may drill down. Selecting the subordinate units dimension, we see that the Army data object consisted of 5 military groups. These units have a number of attributes in the database. Clicking on a column heading in the table permits the selection of any attribute for display in that column. In column 2, the analyst displays echelon, a unit's organizational level, for example, brigade or battalion. Other columns show the total tons of supplies units require, and the number of people in them, both useful to estimate transportation needs. Returning to the outline, the analyst drills down further in the hierarchy to additional subordinate units. The cell entries for the attributes are automatically displayed. This drill-down navigation process can also occur across different relations. For example, the analyst can drill down into one of the brigades to show the types of supplies it requires, thereby switching from an organizational hierarchy to a supply breakdown. Having focused on the units within the 22nd Army Division, the analyst must find those that need the most supplies by displaying these concepts graphically. The selected units are dragged to a display that shows its data objects as bars, in this case, showing the total weight of all supplies each unit needs. Again, in the information-centric approach, data objects are directly moved in groups or individually across application interfaces. Now it's easy to identify and select units with the highest supply needs, those with the longest bars. The next question is where these units are located. So they are dragged to a map and shown as military icons. The map display was developed independently by BB&N, but is coordinated with all other displays. Now it's clear that one of the units is far from the rest and might create a transportation problem. So the analyst locates the supply point to which this unit is assigned using the drill-down operation. The supply point's distance is indeed a problem. Now the analyst must see if it is feasible to relocate the supply point closer and drills down to all the other units it must serve. To estimate the total weight of supplies needed by these units, they are dragged to the table. In addition to drill-down navigation, it is also possible to roll up or aggregate groups of concepts. Here it is simple to create a new ad hoc concept named problem units by applying Visage's compose operator to the highlighted units. The aggregate appears in the outliner, and the total supply requirements for its units are displayed in the table automatically. This process of successive drill down and roll up, selecting subsets and moving them across displays, permits the user to incrementally construct complicated data queries in a powerful and intuitive way. Visage incorporates all the capabilities of Sage, an expert system that automatically designs hundreds of different types of visualization. Currently, Sage is implemented as a separate Lisp program. However, partial integration has been achieved by a drag-and-drop data export function that incrementally populates Sage visualizations with data from the Visage environment. Users can take advantage of current Sage features, including the ability to compose multiple, tightly coordinated visualizations that integrate many types of information. Sage also provides sliders that can be used to filter data in individual or multiple visualizations at once. As we fully integrate Sage into Visage, every visualization will become manipulable using the same information-centric drag-and-drop features as the simpler Visage graphics. The integrated nature of the Visage environment permits a seamless transition back and forth between data analysis and briefing. Users can simply drag or copy their analysis displays directly into a briefing slide. Slides may then be sequenced and arranged in a slide sorter tray to create full-screen presentations. Unlike conventional slideshows, these information objects are still fully interactive for subsequent analysis, even in the midst of a briefing. Thus, any activity in Visage, navigation, selection, analysis, or briefing, can be performed at any time, giving seamless integration of exploration and communication.